I want to introduce Preston Smith. He's our chair for our marketing section. He works at Yale University with Daryl, and I just found out that he started working with glass at age 5. So yeah, he's going to show us the H cell today. It's something that, you know, should I show the little?
Yeah, I can pass this around. This is just the little drawing of technical drawing of what you can make.
And do you want to describe what an H cell is?
It's an electrochemical cell that they use. This one's primarily used in undergraduate laboratories or in the classroom. So we make a bunch of different varieties of these things. I've made different variations on them. It basically has a very fine frit in between the two chambers of it.
What's a frit?
Centered glass disc that allows for filtration. Basically, it allows you to pass stuff through there and like filter very fine particles out of this. These particular frits are fine porosity, which I think is around like 4 to 6 micron size, so it doesn't really allow much to get through there. It basically, when I'm sealing this, it'll act as like its own like stopper. Like you won't really be able to blow through it. I'm going to get started on this. Oh, we buy them just because they're commercially available. Pretty easy, and they're really consistent and don't usually have any problems with them. So I just brought along this holder and stuff. First thing I'll do is I'll make a flat bottom on my piece of 25 here and bead the edge. So that's what I just use this holder to hold it so I can bead these once you cut them because they're kind of hard to hold. I think it was worth it to show that. First thing I want to do before I get started in sealing with the frit is I'm going to pop my holes that I'm going to make my side seals on, because I don't want to do this once I seal that frit, because once you start, I want to get that done. I don't want to cool off. So I pre-marked my spot where I'm going to put my holes. Use Sharpie, and then I go back and I mark it with that titanium pen in the middle. So that will stay on the glass and it won't burn off like the Sharpie will. When I get it up, that little mark will just burn that out. The benefit of the titanium is we can see it. It'll actually light up, and it gives you an idea of where you but
You want me to kind of light toward you?
kind of just like it should glow. There we go. I don't know if you can see that, but you can see how it glows a little bit.
Yeah.
So it gives you an idea of where your mark is. You know where to take glass away from.
You're a pin drop.
Yeah. I'm just cleaning this up to the right size. All right. Flame needle. That's that side done. Repeat the process. side. Work.
How many of these have you made?
I lost count.
That's your first one?
No, I feel like the 100th or something like that.
And do they ever decide they want a different size after you make them?
Not for these particular ones. For some other ones made for researchers, they've come back and wanted extra connections put on them, frit porosities changed, you know, come out guys for something.
Basically, these things are cathode side, one's the anode side.
Yep. Yeah.
Electricity will go through the frit, but the solution won't.
Right, gotcha.
And you're using like the frit made out of fibers rather than the ones that are grain, right?
No, these are grain.
Those are grain?
Well, they're from Robu.
Oh, okay, yeah, I don't know those. Yeah.
What's the
Yeah.
difference? Grain versus fiber.
The fiber ones they're less likely to crack, but I think for filtering they clog up faster. Yeah, because I mean the other ones are just an accident waiting to happen. I mean, they're just barely stuck on the edge.
Like from Ace Glass?
Ace makes a fiber one, yeah.
Yeah, they crack a little easier.
No, do they? Yeah.
Yeah, these ones work pretty well.
Yeah.
Super nice.
Yeah.
Right now, I'm just scratching a mark on either side of the frit where I'm going to seal it. Because if you notice on that drawing, there's a specification for the length in between them. So I do that, but when I go back and heat it, it's going to be really hot, hard to measure.
Explain your holder in there? Yeah.
And yeah, I put a little holder, so you have a smaller piece of tubing in here with just some fiberglass wrap and some tape around it. So it holds the frit right where I want it. So that way I can mark on either side of it. I don't have to worry about it wandering.
If you tilt it the other way, it's going to walk down.
Yeah, it'll walk
You have to
down.
keep it.
I keep it
against
tilted till I get it sealed, and then once it's sealed in there, I don't have to worry about it.
Paper It's
Yeah.
not paper.
It isn't. I thought there was tape on the.
Painter's tape.
A little bit of painter's tape and what is it, fiber fracks.
And so here he has to be careful if he puts too much heat on that frit, he'll melt it all and it will not, work anymore. It won't be good. So you just barely set it in.
Suck in a little bit to get it glass to form down on it. The frit's a little bit smaller. And actually, through the whole process, now you have to be kind of concerned about your heat. Because if you get that frit too hot, it will fuse up quickly. I've done it a couple times. Completely ruined it.
Do you have to on your frits?
What's that?
Do you have to grind the
No, not these ones, no. It's a 12mm frit, 5/8 medium wall tube.
So you can buy frits in all different sizes,
Yeah,
so.
How do you OD grind one of those to precise?
You take the size tube that you want, you crystal bond it to the face, and then you
Yep.
belt sand and grind it, and then
That's
heat
what
it
I
back
do.
up. odd size frit or something that's too large, or you only have coarse frit and you find one.
Yeah,
You can use a diamond sanding pad if you just have to take off a little bit.
Yeah.
Because what when you crystal bond it, I've also used APs on wax, and you got to run it in the oven. And so if you want to get it done quickly, just take a diamond sand pad.
also taking much larger size, use a diamond core drill and drill it out to get kind of approximately the size you want. I'll try to drop my folder out of here if I can.
Yeah, it is.
Yeah, a little bit.
Oh, those tweezers.
Put the tabletop of it. There you go. There you go. There it goes. Oops, sorry.
That's smaller. I didn't grab my smaller tweezers out of the bag.
There you go.
There we go.
Yay!
Perfect. I want to make sure I keep this warm because if you let that cool down too quickly, it's going to crack. Put too much heat on it, it will crack. So I don't have to worry about putting a stopper on that side because that frit will keep it stoppered up pretty well, even though it is open technically. For a coarse frit, I'd have to put a stopper in it. You can blow through it.
That's like the finest frit, more powder frit, right? Presumably when it starts. Keeping,
It's not the finest one you can get, but it's pretty fine.
wow.
I think H sells them as like ultra fine, down to like less of a micron.
Assume the particulate size has to be similar to produce that, so.
Yeah.
You would need a ball mill to get that fine.
Every once in a while we get a call for those.
I'll take a break. I mean, a break.
Mainly here, the goal with the first side seal is just to get it sealed really well. All right, if it doesn't look that great. Because once I go back and I get the other shield side on there, I'll have a holder that's going to brace it so I can go back. I can go back and work that a little better. Yeah, I like to use glass to scratch glass because it doesn't leave as much impurity there in it. If I use a titanium pen, it'll leave a little impurity there. I have to make sure that you pick that out. Not a problem when marking the center of a hole because I'm going to remove all that glass anyway. I'll do that. That's just, make sure to switch my blow hose over, so I can blow through that side. I like to get them set up so that they're parallel, nice and straight. Usually what I'll do is I'll go back with a pair of calipers and I'll double check to make sure that they're straight. And then go back and to readjust them. You don't want them to be off. I'll do a final like check when I'm done sealing it. So while it's still hot, you can go back and adjust it.
What kind of tip you run on your national?
This is number 3,
Piloted or unpiloted?
piloted. I always run piloted for natural gas. Okay.
Seasoned or unseasoned?
This one's been well seasoned. Yeah, typically we only run the non-piloted for the hydrogen. We're doing quartz work.
Yeah, rolling the thing there, is what's on the inside of the wrap? Is that just regular tube?
This?
Yeah,
Yeah, it's just piece 2.
keeping it from sliding out.
That's a woven glass fiber.
This is wrapped around the tube.
Yeah, just wrapped around it. Works pretty well, keeps it sealed. Holds it pretty well. Yeah, so you have to move the blow hose over. Oops.
You're going back to your first side, so.
Yeah, it's prettying up a little bit. Spot it in like. That's pretty much it. Make sure that I flame anneal this really well.
Do you ever just throw it into a hot oven and?
Yeah, I've put it in the hot oven before, but sometimes I'm making a bunch of these, so I'll just, go through and make one, set it down, go and make the next one, make the next one.
He used the diamond set to change the size of that. How do you clean that? That's about it. I think he could handle it. Yeah, I was just thinking the glass part. Yeah. Oh, okay.
If you have to do a lot, you do like what Jared said.
Yeah, yeah.
If you're flaming it out well enough, it'll air cool, just fine. Got a little bit of carbon just to insulate it a bit so that it'll cool down better.
Can you explain what it's used for again?
And then like electrochemistry, they'll put a solution in there and then they'll put the electrodes on either side. And then not too familiar with what exactly they use it for in the labs, but it's like it's on.
You asked me the questions, they start explaining.
That's what it all
Yeah.
You know, I had,
Yeah.
Right over there.
I had one scientist that was using fluorescence stuff on either side. And so then they would take pictures to see how things changed as it went through the filter. Yeah.
It's like different solutions on either side.
Yeah.
Yeah, and different
Well,
electrodes and
Yeah, you would have an electrode on either side, and then your assume, whatever chemical reaction is happening, you would keep whatever particulates form on one side.
yeah. We even made variations of those where they have equalizer tubes on top and stuff. Or other various things, or have ports on the side for sampling, or ports windows. For
You should
stuff.
do a neon one when you get back to the shop.
Maybe I can.
Yeah, so you said
electricity will flow through the frit, but not the solution? Or
Depends on the depends on the porosity of the frit. Certain they'll filter certain things, so stuff that's a small enough size will filter through there. But I mean, water will eventually, like you can pass water through it, but it just takes a really long time. The bore size is so small.
Thank you.
Yay.